Hey, limits to infinity is a very simple concept. It's just asking what value does the function approach as x approaches infinity. For example, this function, as x approaches infinity, the function approaches the value 0. Second function, as the function approaches infinity, the function also approaches 0. So limit as x approaches infinity for this function would also equal 0. It doesn't matter what happens in between. It's just only asking for what happens to the function as it approaches infinity. So this would equal to 0. There are two main strategies to find limits to infinity. First one is substitution, and second is dividing by a common factor. For example, in this case, you would just simply put in the infinity in place of the x. That would equal to 1 over infinity. Then this would approach 0. This is true because as x approaches a really big number and you're dividing 1 by that really big number, it starts to approach 0. Let's look at the second example. Here, you would divide by a common factor of x squared. You try to look for a common variable factor. So this would be 2 plus 3 over x. You divide the numerator and the denominator by x squared in this case. 1 plus 1 over x plus 1 over x squared. What you're trying to do is trying to make as much terms to 0 as possible. So this would actually be 2 plus 0 plus, 1 over x squared plus 0 over 1 plus 0 plus 0, which equals to 2. Lastly, you can use limits to find horizontal asymptotes. For example, if I want to find the horizontal asymptote of 1 over x, you have to first do two things. You have to find the limit as x approaches infinity and negative infinity as you're looking for the horizontal asymptote in both directions. So the first would be 0. And the second would be 0 as well. Therefore, the horizontal asymptote is 0. However, in some cases, the negative infinity side could give you a different value, which is why sometimes there could be different horizontal asymptotes.